In this video, we're going to go over how to solve quadratic equations using completing the square. This is a lesser used technique, so a lot of people don't even teach this technique. If you're taking this as an Algebra 1 course, you might not ever learn this technique in Algebra 1, and in Algebra 2, maybe. But I thought it was something really cool to introduce because it leads into why something called the quadratic formula works. So let's check this out. So what we're going to do is we are going to complete the square and then solve what's left. So to complete the square, if you haven't already gone over those videos, you got to check those out. Otherwise this video is going to be like, what is that? So go over how to complete the square. I'm assuming you know how to do it because I've given previous videos on that. To complete the square, we have this whole part squared and we have the t for t squared, and we divide the b term by 2. So it gives us plus 3. We still have the minus 12 equal to 0. Now from here, we have to figure out what we just added. We just added 3 squared to the problem, so we've got to subtract that also, minus 9. So that leaves me with t plus 3 squared, minus 12 minus 9 is minus 21 equal to 0. All right, so now, I should mention that this we couldn't factor, right? Factors of 12 are 1 and 12, 2 and 6, 3 and 4, none of which are going to add up to 6 or combine to 6. So there had to be another way to solve it. Enter completing the square. Now, what do we do from here? Well, I'm going to add 21 to both sides because what I'm going to do is I'm going to just undo the order of operations. Normally, I'd plug in the answer, I'd add 3, square it, then subtract 21. So I'm going to add 21, take a square root, subtract 3. Let's do it. So I'll add 21 to both sides, undo in the order of ops. That leaves me with t plus 3 squared equals, that canceled, 21. Now I have stuff squared, so I want to undo something squared. I take the square root, and remember it's plus or minus the square root always. Very important. That undoes this, and that leaves us with 2 plus 3 is equal to plus or minus the square root of 21. Now don't worry about the fact that this answer on the right side looks really nasty. You want to undo everything with t. You want to get t alone. So there could be an elephant on the right side of the equation. You don't care. You want to subtract 3 to get t alone. Okay, so we're going to subtract 3 from both sides. T is alone. And what we're left with here is a strange expression, but it would be negative 3, and it would be plus or minus root 21. What that means is you actually have two solutions, either negative 3 plus root 21, or negative 3 minus root 21. This is just shorthand for expanding it out. And those are your two solutions. Remember, what we're finding here is where a parabola crosses the x-axis. And there are two places where this parabola crosses the x-axis, where the y value is 0. So never have that leave too far from your noggin. Now, from here, the decimal values that you get if you were using a calculator is approximately 1.58 or negative 7.58. These are the exact values. It's beautiful. I love it. All right, let's go over a couple more examples. This next one, you might notice, is not set equal to 0. Now, let me just point out, you could actually factor this to find your solution. So we could subtract 10 and then factor it. But I've asked you to use completing the square, so let's do that. So we're going to complete the square. We don't have to set everything equal to 0 since we're going to be isolating things, right? We ended up not having things equal to 0 here. Same here. So to complete the square, I've got stuff squared equal to 10. I've got the x, and now I've got to divide b by 2, so that's 3 halves. No worries, we'll deal with the fraction. So we just added in negative 3 halves squared. So let's figure out what we just added into the problem. 3 halves, negative 3 halves squared, is negative 3 times negative 3 is 9. 2 times 2 is 4. So we just added in a 9/4. So what we have to do is subtract 9/4 so that everything's balanced out. Now some teachers teach this where they say, I added a 9/4 to this side of the equation, so therefore I'll add it to this side. That's the same thing of what we're going to do next anyway. We're going to add 9/4 to the right side. Okay, so now we've got our equation. We've completed the square. Now we're going to solve. We're going to undo the order of operations, add 9/4. Now I realize this is gross. You get x minus 3 halves squared equals, we'll do this fraction work. 10 is 40/4. 40 over 4. And 40 over 4 plus 9 over 4 is 49 over 4. Ah, That's nice. We're now going to undo the square by taking the square root. So you take plus or minus the square root from both sides. Nice. The square root of 49 over 4 is not bad. We've seen that in earlier square root videos. Take the square root of the top, it's 7. Square root of the bottom, it is 2. So if you're having trouble with that, check out way earlier square root videos in my pre-algebra course. So that's plus or minus 7 halves, and that leaves us with x minus 3 halves. All right, so what do we do now? Well, again, we don't care about the ugliness of that expression. We just want to get x alone, so we're going to add 3 halves to both sides. So I add 3 halves, and I know that's weird, but our answers are x equals 3 halves plus 7 halves, or the plus or minus 3 halves minus 7 halves. And if you just take a moment to simplify this out, you're going to see something special. 3 halves plus 7 halves is 10 halves. 10 halves is 5. Or 3 halves minus 7 halves is negative 4 over 2, which is negative 2. And what I said before is that this thing would have factored nicely. And when it did, we would have had zeros that were very nice. So we could have subtracted 10 and factored it. Why do the completing the square? So I wanted to show it to you. All right, one more problem with completing the square here. We'll complete this square. It's not a bad one. So actually a very interesting result too. To complete this square, we would have everything squared, and then that's equal to 12. So y, we're going to divide negative 4 by 2, so that's going to give me minus 2. And now from here, we got to figure out what did I just add to the problem. I just added negative 2 squared, which is 4. So I should subtract 4 from everything to balance it out. Or you could add it to the right side. Right? If I added 4 to the left side, couldn't I subtract 4? Sorry, add 4 to the right side and the left side? If I added it to the left side, I should add it to the right side to balance the equation. That's one way of doing it. So I just wanted to show you that. But honestly, what I like to do is this, where I am just subtracting 4, and then I end up adding 4 to both sides of the equation. It's one and the same thing. So I'll erase that, and I'll solve it like I normally would. I subtract 4 like I normally do to balance out the plus 4, and then I add 4 to both sides to undo the operations. So when I add that to both sides, and you know what? I'm going to change the 12 to a negative to make some interesting things happen. So I'll make that a negative, and watch what happens when I do that. I end up with y minus 2 squared is equal to negative 12 plus 4 is negative 8. So I've got that negative sign there on each of those. Now that I've completed the square, I've got to undo by taking the square root of both sides, and we'll stop right there. You're going to get the square root of a negative number. So even though you have y minus 2 equals plus or minus the square root of a negative number, there's no real number. That when squared gives me negative 8. So there are no real solutions. I'll write that as no solutions, but there's no real numbers that get us there. So when I changed that number to a negative, all of a sudden we had no solutions. Curious. Neat little exploration into how to solve quadratic equations by completing the square. It's a little lengthier. It's your last ditch, I'd say, technique that you would use if isolating by square rooting doesn't work, because you got a B term, or factoring doesn't work. In the not too distant future, I'm going to show you something called the quadratic formula that comes from this. Can't wait.